Welcome to Unit 4 of our chemistry curriculum, where we will explore the world of chemical bonding. Understanding how atoms connect is fundamental to grasping the behavior of matter. In this unit, we will delve into the octet rule, then examine two primary types of bonds, ionic and covalent bonds, and finally, we will discuss electronegativity. Let's get started. First, for 4.1, we're diving into the octet rule, a key concept in chemistry that explains when atoms lose and gain electrons during bonding. What is the octet rule? Atoms strive to fill their valence shell with 8 electrons. This stability drives chemical bonding. Hydrogen, H, and helium, He, are noteworthy exceptions. They only require 2 electrons to complete their outer shell. Atoms can bond in 2 primary ways. First is the transfer of electrons that leads to ionic bonding, where one atom donates electrons, creating ions. The second way is sharing electrons that results in covalent bonding, where atoms share electrons to achieve stability. The octet rule helps explain how atoms interact, forming the foundations of chemical compounds. Next, for 4.2, we're exploring the fascinating world of ionic bonds. Ionic bonds are basically formed between a metal and a nonmetal. In ionic bonding, electrons are transferred from one atom to another. This means that the metal atom loses electrons, while the nonmetal atom gains them. This electron transfer enables both atoms to achieve a stable electron configuration known as an octet. Let's take sodium, Na, and chlorine, Cl, as an example. Sodium loses an electron, transforming into Na+, while chlorine gains that electron to become Cl-. Together, they form a strong ionic bond. Now, as an overview, ionic bonds occur between metals and nonmetals. Next, talking about cations and anions with metal behavior. Metals lose electrons, resulting in a positive charge and forming a cation. As for nonmetal behavior, they gain electrons, acquiring a negative charge and becoming an anion. Remember the terms cations and anions from previous units for clarity on how these ionic bonds form. Ionic compounds are referred to as salts, and the total charge of these compounds, or salts, are always 0. The example shown on the screen is the same one I discussed near the beginning of the video about the NaCl, so if anyone is confused, feel free to rewind. Next up is 4.3 on covalent bonds. Covalent bonds are vital connections that form between nonmetals. In covalent bonding, electrons are not simply transferred, they are shared between atoms. This sharing allows both atoms involved in the bond to complete their outer electron shell, a configuration known as an octet, as discussed earlier. As you can see in the illustration of covalent bonds, atom A, a nonmetal, has unpaired valence electrons. Atom B, also a nonmetal, has unpaired valence electrons. The unpaired electrons from both atoms come together. Through this sharing, they form a stable covalent molecule. Continuing on from what was discussed earlier on covalent bonds, a group of atoms bonded together with covalent bonds is called a molecule. Again, these bonds form when atoms share electrons to achieve greater stability. For example, water molecule, H2O, composed of 2 hydrogen atoms, indicated as H, and 1 oxygen atom, indicated as O. These atoms are covalently bonded, meaning they share electrons. This structure allows water to have unique properties, crucial for life. We can see that understanding covalent bonds is fundamental in chemistry and helps explain the behavior of various substances. Last up is 4.4 on electronegativity. It is essentially the tendency for an atom to attract electrons to itself when in a covalent bond. This is just the periodic table but labeled in terms of electronegativity. We can see that electronegativity increases across a period from left to right. This means elements on the right, like fluorine, are more electronegative than those on the left, like lithium. Electronegativity also increases up a group from bottom to top. For example, fluorine on the top of group 17 is more electronegative than iodine, on the bottom of group 17. The science behind why this happens will be explained next. I just gave you a brief introduction of the trends for electronegativity in the periodic table, but now I will explain why it happens. For the periodic trend, As you move from left to right on the periodic table, electronegativity increases.
Why?
Because more protons in the nucleus lead to a smaller atomic size, which makes it easier for an atom to attract electrons. Ultimately, this results in higher electronegativity values. The group trend is different. As you go down the periodic table, electronegativity decreases.
Why?
Because the atomic radius increases along with more energy levels, pushing electrons farther from the nucleus. This distance results in a decreased ability to attract electrons. Understanding these trends in electronegativity is essential for predicting how different elements will interact in chemical reactions. Now, the question that appears on a screen is something I want everyone to think about. We see two books with two different magnets. Picture A has a thicker book and picture B has a thinner book. Both of these magnets are trying to attract the paperclip. Now, assuming the magnets have the same magnetism and the only difference is the thickness of the books blocking the magnets, which side, A or B, would have a greater ability to attract more electrons, or the paperclip.
And why?
And for the final reveal, the answer was B.
Why?
Well, because in diagram A, there's a weaker attraction because the energy levels, like pages, block more of the magnet from attracting the paperclip. In diagram B, the thickness of the book decreases, which means the magnet can attract the paperclips more effectively. In the same way this concept applies for books, magnets, and paperclips, energy levels can impede the nucleus's ability to attract electrons. Thank you for joining us in Unit 4 of our Intro to Chemistry curriculum. We explored the idea of chemical bonds and learned how the octet rule guides atoms in their quest for stability, leading to the formation of ionic bonds, where electrons are transferred, and covalent bonds, where they are shared. We also learned about electronegativity, the key to understanding how atoms attract electrons. We hope you had fun and see you in the next unit.